Hello students, let us solve this question. This question is from the chapter Waves. The question says a train moves towards a stationary observer with a speed 34 meter per second. The train sounds a whistle and its frequency registered by observer is f1. If the train speed is reduced to 70 meters per second, the frequency registered is f2. If the speed of the sound is 340 meter per second, then the ratio f1 by f2 is, and we have to choose the correct ratio for f1 and f2. So let us start the solution of this question. This question is again from the Doppler's effect. So here a train is moving. Let us suppose this is a train that is moving with a speed 34 meter per second. The speed of this train is, let us suppose this is Vt, is a speed of train 34 meter per second. And there is an observer. An observer is at rest. A stationary observer means velocity of this observer is 0. And train is running towards the observer. The train sounds a whistle. Let us suppose the frequency of the whistle is f. And the observer observe the frequency of the whistle observed by observer is f1. The frequency observed by the observer is f1. In second situation, the velocity of this train becomes 17 meter per second. 17 meter per second, and frequency is again same f, and the frequency now observed by observer 2 is f2. So we have to find the ratio of f1 by f2. So from the Doppler's effect we can write the frequency observed by the observer. As the train is moving towards the observer, the frequency observed by observer can be written as, this is the frequency observed by observer is f0 is f is the frequency of the whistle into velocity of sound plus velocity of observer divided by velocity of sound minus velocity of source. Source is the train, which is Vt. So this is the formula we can use to find the frequency observed by the observer. We can substitute the values in this formula to calculate the observed frequency. Now in case 1, when velocity of the train is 34 meter per second, the observer observe the frequency of f1. So here we can write f1 equals to, f1 is the frequency observed by observer, and let us suppose we have supposed that the frequency of whistle is f. So we can write here f. Now velocity of sound is 340 meter per second plus velocity of observer. Observer is stationary, so its velocity becomes 0. So we can write 0 here. Now velocity of sound is 340 minus velocity of train. In this case, the velocity of train is 34 meter per second. Now this will become, we can write this as 340 divided by 340 minus 34. So this will become 306. So this is the frequency observed when velocity of train is 34 meter per second. Now in second case the velocity becomes 17 meter per second. In this case the frequency observed is f2. So we can write f2 as f2 equals to f into velocity of sound is 340 plus velocity of observer is 0 divided by velocity of sound is 340 minus velocity of train in this case is 17 meter per second. So this will become 340 divided by 323. The ratio of f1 divided by f2 will, the ratio we can write here, the ratio f1 by f2 will become f1 by f2 will be, f1 is this one, so we can write f into 340 divided by 306. f2 is f 340 divided by 323. Now all the same term will be cancelled out, so this will become 323 divided by 306. Now we can factorize this term, so 323 can be written as 17 into 19 and 306 can be factorized as 18 into 17. So 17 will be cancelled, so the ratio will become 19 upon 18. So which option is correct? Option 4 option is the correct answer to this question. Thank you.